Let's go through this AQA GCSE Maths Higher Tier Paper 1. Our first question, multiply a to the 5 all to the power of 3. Well, if it's a power all to the power of another power, you multiply those powers. So it'll be a to the 5 times 3, which is a to the 15, which is this one. Question 2, x is not equal to 0.4, so circle the possible value of x. Well, if we convert 0.4 to a fraction first, well, we can say times 0.4 by 10, which is 4, which means we then have to put it over 10. So it can't be this one, because 4 over 10 is equal to 0.4. If we actually simplify 4 over 10, it goes down to 2 over 5. This will come in handy now, because we can see 20 over 50. If we simplify that down, divide both the top and bottom by 10, we'll get 2 over 5. So it can't be that one, because that's also equivalent to 0.4. 26 over 70. Well, if we divide the top and the bottom by 2, we'll have 13 over 35. 13 is a prime number and doesn't go into 35, so I believe it's this one. And just to double check, the last one, 120 over 300, well, if we divide both the top and bottom by 10 firstly, we'll have 12 over 30. Then divide the top and bottom by, let's go with 3, so we'll be left with 4 over 10. And actually, 4 over 10, that's equivalent to this here, so it can't be this one. So our answer is 26 over 70 is not equivalent to 0.4. Question 3 wants us to circle the solid that has 7 vertices, vertices being those corners. This may seem tricky, but if you draw them out, it's not too bad. So hexagonal prism, we start off with a hexagon. So we've got 6 sides already, and a prism is a 2D shape that goes backwards. So they'll have 6 other vertices on the other side, so this has 12 vertices, so it can't be this one. Hexagon-based pyramid, well, if we've got a hexagon here, if it's a pyramid, we're going to look down and all these points are going to go to the top here. So it's actually got 7 because we have 6 vertices on the bottom and 1 at the top. So it must be this one. Just to double check, pentagonal prism, well, we've got 1, 2, 3, 4, 5. So we've got 5 vertices. Prism goes backwards. So we'll have a total of 10 vertices. A pentagon-based pyramid, again, 1, 2, 3, 4, 5. And if it's a pyramid, it's all going to the center. So we'll have the 5 on the bottom and the 1 on the top. So we'll have a total of 6. So it can't be these two either. Question 4, we've got this graph. It says circle the equation of the graph where k is a constant. Well, it should be nice and obvious, but let's go through each one. Well, y equals kx. If we draw the graph, if it's k multiplied by x, it's going to start at the point 0, and it's going to get bigger and bigger and like that. If we've got y equals k plus x, we're going to have a certain value, so say k is 2. Let's say there, and if we're adding x to it, it's just going to go up in a straight line. Y equals k minus x. Well, if k is, for instance, 5, it might start up here, because 5 take 0 is 5. Then it's just going to go in a straight line down, because we're taking away the same amount each time, which leaves us with the last one, with k over x. Well, if we have 5 divided by 1, that's just 5, so that will be here. And then 5 divided by 10, that would be smaller. And 5 divided by half is going to be bigger, so this is actually going to curve down like that. This is an inverse graph, so it has to be this one. Write 200 as a product of prime factors, give your answer in index form. So we'll start with 200. I'm going to split this down. We could say 10 and 20. Doesn't matter how you split this down, as long as you get the correct answer. 10, that can split down to 2 and 5. Well, 2 is a prime number and 5 is also a prime number. 20, that'll split down to 2 and 10. 2 is a prime number. 10 will split down further to 2 and 5 again. So we've then got 2 times 5 times 2 times 2 times 5. That's just reading across the circled values. Then we've got 1, 2, 3, 2. So we've got 2 cubed multiplied by 1, 2 lots of 5. So 5 squared. Tiny bit trickier. Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. Write Lily's age in months as a fraction of Hugo's age in months. Give your fraction in its simplest form. So what we want to do first is find both of their ages in terms of months. So for Lily's age, well, 2 years, there's 12 months in a year. So 2 times 12 is 24. So 24 months in 2 years, plus the 4 months left over, which gives us 28 months. Hugo's age, well, in 1 year, there's 12 months, so that's 12 months in total, plus the 8 months left over, which gives us 20 months. We want to write Lily's age in months as a fraction of Hugo's age. So that's 28, Lily's age, over Hugo's age, which is 20. And then we want to simplify this because it says give your fraction in its simplest form. Well, I'm going to divide both the top and bottom by 2, so we'll have 14 over 10. We can simplify it even more, divide the top and bottom by 2 again. So I'm going to have 7 over 5. Both 7 and 5 are prime numbers, so we can't simplify that anymore, so our answer must be 7 over 5. If you prefer, you can leave this as a mixed number, which would be 1 and 2/5. Use approximations to estimate the answer to this. And we'll do it bit by bit. We've got root 97, which is close to root 100, plus 2.014 cubed, well that's close to 2 cubed, all over 0.49, well that's close to 0.5. So we can now say root 100, which is a nice 10, plus 2 cubed, 2 times 2 times 2, which is 8, all over 0.5, which is 18 over 0.5, or 18 divided by 0.5. If you divide them by 0.5, it's the same as times them by 2. So the answer is 36. Solve this inequality. Well, first step, I'm going to take away 3x from both sides. So we'll have 2x plus 6 is greater than 15. Take away 6 from both sides. So we'll have 2x is greater than 15 take away 6 is 9. And then divide both sides by 2. So we'll leave x on its own. So x is greater than 4.5. If you want, you can also say it's greater than 9 over 2. So our answer is x is greater than 4.5. Or if you prefer, x is greater than 9 over 2. Both are correct. Write down the inequality represented by the number line. Well, we've got two values. We've got 2 and we've got 5. And its value of x. We now need to determine which symbols we use. Well, this dot is filled in, so this is going to mean that x is greater than or equal to 2, and this dot just means that x will be less than 5. It doesn't include 5 because the dot isn't filled in. For this question, we've got a really important bit of information here, which is x is 1 and y equals 5 are lines of symmetry. They've actually drawn these lines on here for us. We want to work out the coordinates of point Q, which is here. And we need to start off at point P, which is here. And what we're going to do is work out the x coordinate first and then the y coordinate. So for the x coordinate, we start as -2. And then we're saying, how do we get from here to this line of x equals 1? Because the distance from here to here is the same distance from here to here. Well, from -2 to 1, what you have to do is add 3. So then what we're saying is, well, how do you get from this point here to this point here? Well, it's the same distance from these 2 points to these 2 points. So we go from x equals 1, and to get to Q, we need to add 3. So therefore, we'll say 1 plus 3 must equal 4. So there's our x coordinate. Next we'll work out our y coordinate. Well, we're starting off at -6, and we want to get to this line of symmetry here, which is 5. So we're going from -6 to 5. And to get from -6 to 5, we want to add 11. So to get from 5 to Q, which is from here to here, but it's a line of symmetry, so we could be saying we're going from here to here, we want to add 11. So 5 plus 11 is 16, which is our y coordinate. So therefore our final answer, Q, is 4, 16. Work out 2,000 times 70,000. Give your answer in standard form. 2 ways you could go about this. I'm going to show it both ways. The first way, I'm going to change both 2,000 and 70,000 into standard form. So 2,000 is 2 times 10 to the 3, and we're multiplying it by 70,000, which is 7 times 10 to the 4. Well, 2 multiplied by 7 is 14, and 10 cubed multiplied by 10 to the 4 is 10 to the 7. However, in standard form, this value has to be between 1 and 10. So this is going to be 10 times smaller, which is 1.4, which means this has to be 10 times bigger, which is 10 to the 8. So our final answer is 1.4 times 10 to the 8. Do not forget to change this, so this value is between 1 and 10, or you could lose a mark. The second way of doing this, which some may prefer, is just multiplying out this value to begin with. So we've got 2 times 7, which is 14, and then all these zeros added on or multiplied on at the end. So we've got 1, 2, 3 from the left-hand side and 4 from the right. 1, 2, 3, 4. I'm going to put the commas in so I can see the number easier. So we can see we've got 140 million. And then we can just change this into standard form. You know the numbers shift along the number line, but the decimal looks like it's moving along. So if we've got decimal here and we want it between 1 and 10, so it's going to become, so it wants to be between 1 and 4. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we've got 1.4 times 10, and we said 8, so it'll be to the power of 8. So both ways work. I prefer the method on the left-hand side as it's much easier, quicker, and more mathematical. Probably can make less mistakes that way. We now want to work out this, which we want to leave the answer as an ordinary number. There's a couple of ways you could go about this again. I'm just going to show it one method this time. So I'm going to break it up to say, well, 1.8 divided by 3 first. So 1.8 divided by 3. How you do that is up to you. You could do it as 1.8 divided by 3. 3 doesn't go into 1. 3 goes, so we'll carry that over. 3 goes into 18 6 times, so it'll be 0.6. And then we've got 10 to the 2 divided by 10 to the minus 1. Remembering your power rules, that's going to be 10 to the 2, and then taken away because we're dividing, and then the minus 1. So that will be 2 take away minus 1, which becomes 10 of 2 plus 1, which becomes 10 cubed. So putting this together, we've got 0.6 multiplied by 10 to the 3, so 0.6 times 10 to the 3. I'm going to put it into proper standard form, so 0.6 is between 1 and 10, so we'll have 6 times 10 to the 2. You don't have to do that part, I just prefer to do it. And either from this step or this step, whichever way you prefer, I'm doing it from this bottom step. 6 times 10 squared is the same as 6 times 100, which is 600. If you did it the top way, you'll have 0.6 times 10 cubed, which is 1, 2, 3, which is still 600. This one's a bit of a hefty question and requires a bit of thinking. A, B, C and D are junctions on a motorway. Distance CD is 3 times the distance of AB, and distance BC is 25 miles. So I'm going to highlight the distances to make life a little bit clearer. So B to C is 25 miles. C to D is 3 times the distance of AB. So we've got these two bits of information drawn on, so it's a bit clearer. We're now saying Salma drives from A to C. I forgot to highlight the question, which is work out the distance AD, which is this one here. Salma drives from A to C. She drives for 30 minutes at an average speed of 62 miles per hour. However you work that out is up to you. Well, I was saying if she drives 62 miles, we'll put A to C. If she drives 62 miles in 1 hour, well, therefore, in half an hour, she must drive 31 miles. So on the diagram, I'm going to write that, so 31 miles. So at this point, so the two values we've got missing are from C to D and from A to B. Now from C to D, it's actually 3 lots of AB. So we need to work out AB now, and we've got the information to do that, because we've got the total distance from A to C, and we've got the distance from B to C. So we can say A to B is the distance from A to C minus the distance from B to C. So the distance from A to B is A to C, which is 31 miles, which we've just calculated, minus the distance from B to C, which is 25 miles. So A to B is 6 miles. I'm going to draw that, or write that on the diagram here. So we've got 6 miles. So the final missing piece of information is the distance from C to D, which we've already said is 3 lots of AB, which AB is 6 miles. So So we can say that C to D is 3 lots of A to B, which is 6, and that equals 18. So C to D equals 18. Last step, well, we need to find the distance from A to D. So A to D is 6 miles from A to B, plus 25 miles from B to C, plus 18 miles from C to D. 6 plus 25 plus 18 is 49, so therefore our answer is 49 miles. Here is a right angle triangle. Use trigonometry to work out the value of x, x being here. Well, the first step in SOHCAHTOA is labelling the sides. So we've got the hypotenuse, the opposite, and the adjacent. The sides we need are the opposite and the hypotenuse and this angle here. I'm going to write down SOHCAHTOA so I can figure out which one to use. SOHCAHTOA. Well, we need the opposite and the hypotenuse, and that's in this one here. So we can discount them. I'm going to rewrite this nicer. So we need to write out the formula now. So we need to find the opposite side. So opposite equals what's left over is sine of the angle multiplied by the hypotenuse. Substituting the information, well, the opposite is x. Well, x equals to sine of the angle, which is 30, multiplied by the hypotenuse, which is 10. I'm going to rearrange that so it looks a bit nicer. So 10 multiplied by sine 30. Now we don't have our calculators for this, which makes life a little bit trickier. So use your method to remember the exact values, because we'll need to find the exact value of sine 30. My method is to do with drawing the hands. I'll have 0, 30, 45 degrees, 60 degrees, and 90 degrees. And then we are after sine of 30, so that's this one here. And our formula is root fingers over 2. And because it's the sine, we're looking at the right-hand side, so there's just 1 on the right. So therefore we've got, so sine 30 is root 1 over 2, which is just, well, root 1 is a 1, so sine 30 is a half. So x equals 10 multiplied by a half, which means x just equals 5. So the answer is 5 centimetres. If you've not seen this method and want to learn it, I've put a link to a video in the description below. Convert 5 over 6 to a recurring decimal. There's a couple of ways you could do this, whichever way you want to. I think the easiest way is just to say 5 divided by 6. And then I'm going to put the decimal places in there and a few zeros. Well, 6 goes into 5 0 times, so we cross it out and carry it over. 6 goes into 50 8 times with 2 left over. 6 goes into 20 3 times with 2 left over. And 6 goes into 20 3 times with 2 left over. So you can see here, we're going to have a recurring value, which is 3. So it's going to be 0.83333333333. So our final answer will just be 0.83 recurring. So the decimal place wants to be over that 3. A nice simple one. Simplify 3 over x plus 4 over x. We've got the same values. Well, we've got the same denominator, so it'll be 3 plus 4 over x, which is just 7 over x, which is this one here. Bit of a trickier question again now, but it's just a bit of quadratic equations with a little bit of thinking. What you'd want to do first is worry about this side and say, well, this is equal to that side, so let's get this in a form where we can compare it against this side. So I'm going to expand these brackets out. So if I draw the grid, we've got x plus a, and then x plus 3a. Well, x times x is x squared, x times a is plus ax, x times 3a is plus 3ax, and 3a times a is plus 3a squared. Write these values out, so we'll have x squared plus ax plus 3ax plus 3a squared. And then simplify it down because we've got two like terms. We've got x squared plus 4ax plus 3a squared. Now we can compare this equation with this equation here. We know that plus 4a is going to be the same as b, and plus 3a squared is going to be the same as 75. Now we don't know the value of a currently, but we do know the value of 3a squared, because 3a squared is equal to 75. So all we need to do here is solve for a. Well, first step is divide both sides by 3, so we'll have a squared, which equals 75 divided by 3, which is 25. And then to find a on its own, we're going to square root both sides. So a equals plus and minus 5. Remember, we've got two possible values of b, so that should give it away that this has two terms in it. And because it's a square root, 5 times 5 is 25, but minus 5 times minus 5 is also positive 25. So be wary of that. That's actually one of your marks there. That'll be another mark. Our last step then, we want to find b. We know 4a is equal to b. We know our a value, which is plus or minus 5. So firstly, if we say input our plus 5, we'll have 4 times 5, which is 20. So that's one of our values. And then if we input minus 5, 4 times minus 5 is minus 20. There's our second value. So work out two possible values of b, which is 20 and minus 20. Looks tricky. Just use your quadratic knowledge and then compare the values. A bit more of a beefier question here. Be careful not to make any mistakes. We've got the cumulative frequency graph, which represents the masses of 40 necklaces. The first question for A jeweler buys every necklace with mass greater than 21 grams. So be wary, greater than 21 grams is highlighted greater than, so you don't make any mistakes, and to be very wary of that. Use the graph to estimate how many she buys. So we're looking for an amount. Well, if we want to find the amount of necklaces greater than 21 grams, we need to find how many are up to 21 grams. So I'm going to go to the mass at the bottom, which of 21 grams, which is here. And then I'm going to go up until the point where it reaches the curve. And then I'm going to go across. You'll do this with a ruler in the exam. So it actually reaches 16. So 16 are less than or equal to 21 grams. But we, remember, are looking for greater than 21 grams. Well, we've got a total, as it says up here, of 40 necklaces. So we've got 40 necklaces in total, minus anything that's less than or equal to 21 grams, which is 16. So 40, take away 16, which is 24 necklaces remaining. So the answer is 24 necklaces are greater than 21 grams. Part B of this question, the lowest mass was 3 grams, the highest mass was 28 grams. Draw a box plot to represent the data. You may have heard this being called a box and whisker diagram. The first thing I'm going to do is draw these 2 points on the graph. So we've got 3 grams, which is here. Make sure I draw this with a ruler. And then we've got 28 grams, which is, we've got 25, 26, 27, 28, which is here. And then I'm going to draw a line between them. It doesn't matter too much if that's central or not, but get it as central as you can. So now we need 3 points. We need the point at 50%, the point at 25%, and the point at 75% to get our box. Well, we're going to have to go back to our graph to find this. So we've got 25%, 50%, and 75%. So 25%, 50%, and 75% are of these values here on the side, the cumulative frequency. So 100% is all 40, 0% is 0, obviously. So 50% is going to be half of 40, which is 20. So 50% is 20. Just going to put that there. 25%, well, it's half of 20, or a quarter of 40, which is 10. And 75% is 30. Now, these are not the values that you're going to input into the box and whisker diagram, because the box and whisker diagram are looking for the grams, the masses, as you can see here. So what we're going to do is use this graph to find the grams using these values here. So I'm going to draw 25% first, which is 10. So we're going to start at 10, going to move along up until it reaches the graph, and then we're going to go right down until it reaches the bottom line, the bottom axis, which in this case we've got 16, 17, 18. So this is 25% is 18 grams. 50%, well, it's at the 20 mark. So we'll go from 20, go right along. Again, use your ruler for this. I'm going to go right down till we get our answer, which is 22 grams. And then finally, our 75% is at the 30 mark. So start at 30, work your way along. And then once it reaches the line, cumulative frequency line, and go right down. At this point, it's 24 grams. So we've now got 18 grams, 22 grams, and 24 grams. And just to let you know, this is worth 1 mark. These two values together is also worth 1 mark. And the final mark for this is then drawing in the diagram. So drawing in our 25%, 50% and 75% values. Firstly, 25% is 18 grams. So I'm going to draw that on. So we've got, which is here, with a straight line, use your ruler. Do it a bit smaller compared to the outer lines. I've got 50%, which is 22 grams. So 21, 22. Which is about there. And 75%, which is 24 grams, which is 2 along from there, 1 less than 25, which is there. My lines are a bit dodgy, don't worry about it. You can rub it out in the exam. I'm just going to edit them here. So now we've got 3 lines. We want to make it into a box, so we can draw a straight line across the top and the bottom. And there we have it, our last mark, our box plot to represent the data. Remember not to draw in red or anything in the exam. Draw in pencil. I've just drawn it in colour, so it's easier for you to see. 17 is quite a nice one. Circle the vector that translates the points -2, 7 to the point 3, -1. Well, focusing on the x values, we've got -2, and that translates to 3. It's just for the x values. Well, you add 5 for this, so we know we're going to have 5. And then we've got, for the y values, it starts at 7, and it translates to -1, which to go from 7 to -1, you take away 8, so -8. So therefore it must be this vector. For this question, we've got this triangle, and it says, give a reason why the length of side AB, which is this side here, cannot be 35 meters. There's a few different ways you could explain this, but the one key thing you need to do is say, well, what's 17 plus 13? Well, 17 plus 13 equals 30 meters. Why can AB not be 35 meters? Well, AB can't be bigger than 30 meters, because otherwise AC and CB won't even reach. So it can't make a triangle. It won't be as long as AB. So it wouldn't be a triangle. So we could say, actually, AB cannot be bigger or be greater than 30 meters. Any simple explanation like that will get you the mark. It's only 1 mark. There's different ways to show it. But what I'd recommend is doing the calculations, because that is always a nice, sure way to say, well, now you know mathematically that this can't be bigger than these two added together. Here is a different triangle. Leah tries to use the sine rule, that's the most important part here, the sine rule, to work out the size of angle X, which is here. Here are the first 2 lines of her working in this box here. What error has she made in this working? Well, the error actually started in this very first line. If you write out the sine rule, it's actually got to be sine of the angle. So it should actually be sine of x over the value of the length opposite equals sine of the other angle, which is 72 in this case, over the opposite side length, which is 54 in this case. And then she can rearrange to say, well, sine x equals 31 sine 72 over 54. So writing something like that will get you the mark. It's only a 1 mark answer. You could write an explanation. You could say x and 31 should be swapped. She has used 31 as an angle. She's used x as a length. Something along those lines. Just write that down. Make sure you write it in the area below. I've written it here so you can see the whole question on the page. And write little explanations such as she has the length and angle swapped. Something like that will get you the mark. Question 19 is a nice probability question. Items made out of factory have to pass 2 checks. 90% pass the first check, the items that fail are scrapped. 99% of the items that pass the first check pass the second check. The items that fail are also scrapped. Complete the tree diagram. Well, with our first check, just focusing on this bit first, if 0.9 pass, well, this and this have to add up to 1. So this value here must be 0.1. So in the first check, 0.1 or 10% fail. For the second check, we've got to say, well, what's the fail rate and what's the pass rate? Well, the pass rate, it says, is 99%, which converting that to a decimal is 0.99. So 0.99 pass. Therefore, 1 take away 0.99 is 0.01. So 0.01 fail. 2 very easy marks for you. That's 1 mark. This is another mark. An item is chosen at random before the checks. Work out the probability that the item is scrapped. We need the probability that it will be scrapped. Well, looking at the tree diagram, we can see that in the first round, there's a 0.1 chance that it will fail. So we're going to write that here. So we've got I'll put in the first check, be 0.1 that it fails. I'm going to add the second check. But you don't just say, well, we're going to add 0.01 because the chance of this happening anyway is 0.9. So we're going to have to say, if it passes the first round, I'll highlight this, if it passes the first round, it's then going to have to fail the second round. And to find this probability, it's the first probability times the second probability. So 0.9 multiplied by 0.01. I'm going to write that again further down. So 0.9 times 0.01. Remember, you've not got a calculator, so make sure you know how to multiply and divide by 10, 100, 0.1, etc. In this case, 0.01. So this will become 0.009. So we've got the probability it will be scrapped in the first round, plus the probability it will be scrapped in the second round, and altogether that will give us a probability of 0.109. Question 20, a quick one. Which one of these is a unit of density? Well, density is about mass, so we know the first part is going to be about grams because we're talking about the weight of something. So it can't be these two because the first part is to do with centimetres squared or centimetres cubed. So then we're saying it's got to be one of these two because it's grams per watt. Is it going to be centimetres squared or cubed? Well, if we're talking about squared, it's talking about over an area, but if it's talking about cubed, it's talking about the volume of something. So because it's density, we're talking about 3D space, so we're talking about the volume. So it has to be grams. So it has to be grams per centimetres cubed. Question 21 is quite a tricky question for GCSE. The first two terms of a quadratic sequence are 10 and 17. A quadratic sequence, so it means we're going to have a sequence of an squared plus bn plus c. Here is some information about the sequence. It's actually given us most of this, which is quite nice. So we just need to fill in the details. Well, it's given us the sequence, the first difference of this, and the second difference. So this is the difference of this. So we need to fill in this information first, or we need to work from the bottom up. So you add 6 each time here. So 13, add 6 becomes plus 19. So then we can work out from 17 to here is plus 13, which is 30, and then 30 plus 19 is 49. We now need to work out an expression for the nth term of the sequence. Well, the first step is working with this bottom part here, the second difference. What you need to do here is going to be something n squared, and that something is relating to this. It's actually half of this value, so it will be 3n squared. So now we know this part of the sequence. What we need to do is write out the sequence just with 3n squared. So we'll put n, 3n squared. I'm just going to draw a little table for this. We've got 1, 2, 3, 4. And if you find this hard, you can also just write n squared here. So we've got 1, 4, 9, 16. So 3 lots of that is 3. 4 times 3 is 12. 3 times 9 is 27. 4 times 16 is 48. Now we've got this sequence here. What we need to do is take the original sequence, which is this sequence here, and subtract the new sequence. So we've got 10 take away 3 for the first one. So we've got 1, 2, 3, and 4. So 10 take away 3 is 7. Second sequence, we've got 17, the original. So original take away new. 17 take away 12, which is 5. Third sequence, we've got 30 take away 27, which is 3. And the fourth sequence, we've got the original, which is 49, take away the new, which is 48, which equals 1. So this is our leftover sequence we need to solve. And as we can tell, it's just subtracting by 2 each time. So we know it's going to be a nice linear sequence at this point. So it should be bn plus c. Well, if it's subtracting 2 each time, we know it's going to be minus 2n. So then we can say, well, actually, put this in a table, n, so minus 2n. 1, 2, 3, 4. So minus 2, minus 4, minus 6, minus 8. Then how do we get from this to 7, 5, 3, and 1? Well, to get from minus 2 to 7, you need to add 9. To get from minus 4 to 5, you add 9. Minus 6 to 3, add 9. And funnily enough, minus 8 to 1, you add 9. So this sequence must then be minus 2n plus 9. Altogether then, we've got a final sequence of 3n squared minus 2n plus 9. So 3n squared minus 2n plus 9. Tricky question to remember how to do, but worth a nice 4 marks. Question 22, this is very nice for 3 marks. Work out the value of 5 over 7 all to the power of minus 2. If you've got a minus power, this is just the same as the power of the positive reciprocal. What I mean by this is, firstly, if we've got a minus, you want to write the reciprocal of this, which is 7 over 5. So that's the reciprocal. And then the minus 2 will become positive 2. So we've dealt with the reciprocal, and now we just have to deal with the fraction to the power of 2. Well, this is the same as 7 squared over 5 squared, which is 49 over 25. So we've now got our improper fraction, but we want this as a mixed number. So we can say 49 take away 25 is 24. So we've got 1 whole 1 plus 24 over 25 left over, and we can't take away another 25 from the 24, so it's just 1 and 24 over 25. One of my favourite questions, which is rearranging to make x the subject. Well, if we've got the x value down here, what we want to do is multiply both sides by that root x plus 1, so we can get the x value on the top. So multiply both sides by root x plus 1. So we'll be left with y root x plus 1, which equals 1. We want to get this x plus 1 value out of this square root, so we need to square it, which means we're squaring everything else. So that will leave us with y squared, lots of x plus 1 equals 1 squared, which nicely enough is just 1. We want to divide both sides now by this y squared, so we'll be left with x plus 1 equals 1 over y squared. And then finally, we want to eliminate this plus 1 from this side, so we take away 1 from both sides, which will give us x equals 1 over y squared minus 1. So our final answer will be 1 over y squared, take away 1. There are a couple of variations of the answer. Some of you might have wanted to do this bit, where y squared is the common denominator, in which case you'd have had 1 over y squared minus y squared over y squared, which equals 1 minus y squared over y squared. And that will also be correct. Bit of a weird question, this one. Be a bit careful with this, but actually it works out really nicely. I'll talk through the process of how to go about it, and you'll start to find actually it's what you've seen before in a strange format. So we've got f of x equals cx plus d. Now, these two here, f of 4 is 7 and f of 10 is 22. All that's saying is when you input x into here, so if we input 4, this will be 4c plus d, and if we input 10, this will be 10c plus d. So we're going to write that down. So when you input, so when x is 4, this becomes 7. So when x is 4, so we'll have 4c plus d. All I've done at this point is input x as 4. And then that will equal to 7, because it tells you here. We then have, if we input 10 as our x value, we'll have 10c plus d. And that will equal, or the output is given us as 22. This now all of a sudden looks very familiar because they're simultaneous equations. Now they've given it in a nice format because we don't have to do any multiplying of the equations because we've got two values the exact same. So we can just do the first equation, take away the second equation. So if we have 4c take away 10c, that will give us minus 6c. D take away d is 0, and 7 take away 22 is minus 15. So we just have to rearrange it. So I'm going to actually add 6c to both sides to give us 0 is 6c take away 15, and they're going to add 15 to both sides to have 15 equals 6c. Divide both sides by 6 now, so we'll have 15 over 6 equals c. Simplify that fraction. I'm going to divide the top and the bottom by 3, so we'll have 5 over 2 equals c. So c is 5 over 2 or 2.5, depending which way you want to go about it. We want to input c back into one of these equations. I'm going to input it in the top one because it's less working out for us to do. So we've got 4 lots of, I'm going to use the fractions, 5 over 2 plus d equals 7. 4 times 5 over 2 is 20 over 2 plus d equals 7, which means 10 plus d equals 7. Take away 10 from both sides, so d equals minus 3. So we've now got our values for c and for d. So write that at the bottom, c equals 5 over 2 and d equals minus 3. If you prefer, you can write c as 2.5. That's just your preference, which one you prefer to use, to be honest. B, we've got g of x equals 2x and h of x equals x minus 1 over 2, and we want to circle the expression for h of g of x. Now I don't like how that's written, because I prefer it to be written as h of g of x. Meaning we're inputting g of x into h. So h of x, we've got this x value that's going to be input, and that x value is actually going to be this g of x value, which is 2x. So we replace the x value with g of x, for instance, g of x minus 1 over 2. So g of x is 2x, so it'll be 2x minus 1 over 2, which is this one. This is a subtly nice question. We also know this because it simplifies as an integer. Now you need to remember how surds work for this. My first set would be, let's just simplify so far. So we've got root 150 minus root 6. I'm going to simplify the bottom. So root 2 multiplied by root 3 is root 6. And I've done this because actually we've got a root 6 here and a root 6 here. So I pretty much have a strong feeling that we're going to get a root 6 when we deal with this root 150. So over here I'm going to write root 150, and I'm going to assume we're going to have root 6 lots of root something else. To do that, we need to do 150 divided by 6. 6 doesn't go into 1, so the 1 carries over. 6 goes into 15 twice, with 3 left over, and 6 goes into 30 5 times. So we've now got root 6, root 25. So I'm going to replace this root 150 with root 25 root 6 minus root 6 all over root 6. And actually root 25 is a square number, so this will become 5 root 6 minus root 6, all divided by root 6. We can simplify this top line because 5 lots of root 6 take away root 6 is just 4 lots of root 6, and then divided by root 6. And lastly, we've got this root 6 here and root 6 here. So we can divide this entire numerator by root 6, because root 6 divided by root 6 is 1, so we're just left with 4. So you'll get a mark for this bit, a mark for this bit, and a mark for the final answer. Another weird question now. We want to work out the ratio of e to the f, given this information here. Again, this is another question where there's multiple ways to go about it. My first step is I'm going to focus on this equation here, but I want to get rid of this d, so we just have two variables in this. So we'll just have e's and f's. And we know that d is equal to 2f. So I'm going to replace this d with 2f. So we'll have e minus f over 2f minus e. And that equals to 1/4. I'm actually going to show this two ways to you. So I'm going to show you the algebraic way first. So I'm actually going to multiply both sides by this 2f minus e. So we have e minus f equals, well, 1 lot of 2f minus e is 2f minus e, and then all over 4. Then multiply both sides by this 4 here. So we've got 4 lots of e minus 4 lots of f equals 2f minus e. I'm going to add e to both sides. So we've got 5e minus 4f is 2f. Then add 4f to both sides. We've got 5e is 6f. Now, if we want to find e, we're going to divide both sides by 5. So we'll have e equals 6 over 5 lots of f. Or if you want to find what f is, you divide both sides by 6. So 5 over 6e equals f. Now this is where you've got to be really careful. I'm going to choose this e equals 6 over 5 lots of f. So if we've got e, we've got f. If f is 1, for instance, e is 6 lots of 5 of f, so that e is 6 lots of 5. So our ratio so far is 6 over 5 to 1. Now we want to make these integers or whole numbers, so I'm going to multiply both sides by 5 to make both sides 5 times bigger. That will give us 6 to 5. So we've now got a final ratio. However, there is a different way of doing this, which I prefer because it's less messy and I feel like there's less mistakes can be made. If we have e minus f over 2f minus e is 1 over 4, well, what we can actually state is this numerator must be equivalent to this numerator, and this denominator must be equivalent to this denominator. So this is equivalent to this, and this is equivalent to this. So this numerator will have e minus f equals 1, which is our first equation. And if I rearrange the denominator, we'll have minus e plus 2f equals 4. So we're doing simultaneous equations instead. And what we can do, we can actually add these two equations together because e plus minus e equals 0. So we'll have, so add in them, so we'll have e add minus e, or e take away e, equals 0. Minus f plus 2f equals just 1f. 1 plus 4 equals 5. So already we found out that f equals 5. And all we have to do now is input f equals 5 back into one of these two equations. Well, I'm going to use the first one because it looks nicer. So I'm going to say e minus f, which is 5, equals 1. Add 5 to both sides. So we'll have e equals 6. And we now have the value of e. And then it says work out the ratio e to f, which is, so e to f, which is 6 to 5. So we've then got our answer of 6 to 5. So this way is much nicer because you have to be very wary with how you go about it with the algebraic point here. So I'd recommend doing it in the simultaneous method. Another hefty question now. The vertices of a regular hexagon lie on a circle with centre O and radius 5 centimeters. Work out the shaded area, which we can see here. Give your answer in the form a pi minus b root c all over 12, where a, b and c are integers. Now we can probably assume the answer will leave us with this form anyway. Don't worry about having to put it in that form because the answer will naturally lead us to that. We also don't have calculators, so we're going to have to leave it in pi insert format. But let's get started. One of the most important bits of information is the area of a circle, which you should know is pi r squared. That's very important. And the sector of a circle, because we're only dealing with the sector, is we've got 60 degrees over 360 degrees. So that's the proportion of the circle, which that will simplify down to 1 over 6. You can do this in steps and say divide by 10, which is 6 over 36, and then divide by both top and bottom by 6, which will give us that. Now what we want to do first is find the area of the sector of a circle to get this whole amount, before we find the area of the triangle to subtract away from it. So the area of a circle, which is pi r squared multiplied by the sector of a circle, so sector angle over 360, import that information, so we'll have pi, lots of, well the radius is, we can see here, it's 5, so 5 squared multiplied by the sector, which we simplify to 1 over 6 here. That will give us 25 pi over 6. So this is our circle sector area. But now we need to find the area of this triangle. This gets a little bit trickier because we don't have the height. You could use Pythagoras, but for this I'd recommend using trigonometry. Scroll down a bit, because the area of any triangle is half AB sine C. And we've got the values of A, B and the angle C. So I'm going to import that information. We've got half, lots of A, which is 5, B, which is also 5, and sine C, so we've got sine of 60. So we've got 5 times 5 is 25, so we've got 25 over 2, lots of sine 60. Use whichever method to find the value of sine 60. I'll use the hand method, so 0, 30, 45, 60, 90. We're after 60 degrees, and we've got root fingers over 2. So because it's 60 degrees, we've got 1, 2, 3 fingers to the right, so root 3 over 2. So this will equal 25 over 2, lots of root 3 over 2. Multiply these fractions, so 25 times root 3 is 25 root 3, and 2 times 2 is 4. So we've now got the area of the triangle. All we need to do now then is say, well, this whole sector, which we've got here, subtract this triangle within the sector, will leave us this little bit here, which we're trying to find. So we've got the whole area, which was 25 pi over 6, subtract the triangle area, which was 25 root 3 over 4. Now we don't know the exact values, we're not going to work them out. Is what we do want to do is change these into equivalent fractions that have a common denominator, because they don't currently. I'm going to scroll down the page a little. So a common denominator of 6 and 4 is 12. So I'm going to put over 12 minus over 12. Now 6 multiplied by 2 is 12, so 25 pi times 2 is 50 pi. Then 4 multiplied by 3 is 12, so 25 root 3 multiplied by 3 is 75 root 3. And then because we've got a common denominator, we can just merge the tops, which is 50 pi minus 75 root 3, all over 12. And looking back at the question, it says here a pi minus b root c over 12. we've got that. We've got a pi, which is 50 pi, minus b root c, minus 75 root 3, and 12 at the bottom. So it's worked out really nicely to give us 50 pi minus 75 root 3 all over 12 centimetres squared. Here is the graph of y equals cos x right here, between the values of 0 degrees and 360 degrees. In parts A and B, the graph of y equals cos x right here is shown as a dashed line. So this will be represented by a dashed line for the following questions. On the grid below, draw the graph of y equals cos x minus 90 degrees. Now, when it's got minus 90 degrees, so when it's within these brackets, you don't shift it to the left, you actually shift the cos diagram to the right. So it's actually going to go 90 degrees to the right. So this point here will shift 90 degrees to here. This point will shift to here, and so on and so forth. So I'm actually going to draw all the points shifted. So this 90 degrees will actually go here. We're going to have a point there and there. So we can say, so it can look like this. And then this will actually carry on going down there. That will be at the point 0. And that's the answer for this one. This graph, we've got y equals 1 plus cos x. Well, if y is 1 more than it would be, well, y is going to be shifted up by 1. So it's actually going to, we're going to have a value there. This is going to shift up to here. It's going to shift up to here, to there, and to there. So I'm going to draw it now. That's one of the dodgiest drawings I've done in a while for the cos graph. There we go, that's a bit better. This is why you do this in pencil. And we've now got the graph of y equals 1 plus cos x. This last one is an explanation. Rita tries to draw the graph of y equals cos minus x. Give a reason why Rita's graph is incorrect. Now, if we draw the cos graph, it looks like this. If we carried on drawing it backwards, it would look like this. Notice it's a mirror image. So when y is cos x, so here, minus x is going to be here, so the values will always be the same. But one nice reason, if you input, for instance, x equals 0, so when x is 0, y is cos of 0, you'll note that cos 0 equals 1. So 0 is the same in either value. So if cos of 0 equals 1, then the graph must start here. You're going to have to put this into your own words. Put this into your own words mathematically. I'd say, well, f of x equals f of minus x. But you can also say, well, f of 0 is 1. So therefore, Rita's graph is wrong. You could also say cos of x graph reflects in x equals 0 line. Many explanations. Put it into your own words. Here's a variety of reasons why. But it's worth 1 mark, so don't wreck your brains over it. There's some explanations as to why. Last but not least, we've got this question here. Here's a triangle ABC on a grid. It says, describe a single transformation of the triangle so that point B is invariant, point A moves to 1, 1, and point C moves to 1, minus 1. Well, point B is invariant basically means it doesn't vary, so that's going to stay in the same place. Point A moves to 1, 1, so point A moves to 1, 1, which is here. I'm going to call it A dash. And point C, which is this one, moves to 1, minus 1, which is here. Means we can now redraw this triangle, so it goes to here, here, and here. Make sure you draw this with a ruler. I've got to write C dash here. All we need to do now is say, well, what's the single transformation that happens to this triangle? Well, we can see, actually, the B's in the same place, which is a really handy trick to think. And this, the triangle looks the opposite. So actually, it looks like it's actually rotated. In this case, it has. So firstly, we're going to say it's rotated. So rotated, or rotation, it's up to you, rotated. We can see it's rotated 180 degrees. So that's actually 2 marks. We said it's rotated, and by how much. But where's it rotated around? Well, we can say it's by this point here. So about, you You can say around, but about's more correct. About point B. I'm just going to write point B, which is -1, 1. And that will get you your 3 marks. That is the last of the questions. Thanks for watching. Any questions, pop in the comments below, as well as any requests. Other than that, stay safe and healthy, and I'll see you in the next video.